Hello everyone, I'm Tejal Salunke. I'm an intern volunteer at Forensic Fusion, and today I'll be talking about mass spectroscopy. It is one of the most widely used techniques in molecular analysis in organic chemistry. So today we'll be talking about what is it, what is its principles, the instrumentation of it, also the applications of it, and its working. So now moving into the topic, let's begin. Um, Mass spectroscopy is a powerful microanalytical method that can identify the molecular structure and molecular weight of a compound using just a small sample, sometimes only nanomoles. Unlike the other spectroscopic methods that rely on interaction of molecules with electromagnetic radiation, my mass spectroscopy is just concerned with the ionization and fragmentation of molecules. During this process, the sample is bombarded with energy, typically the electrons, causing it to break apart into ions. This mass spectrometer then measures the relative abundance of these ions, producing a unique pattern known as mass spectrum, which can be used to identify the compounds. So, um, this is why mass spectrometry is often referred to as a destructive method because the sample is consumed during the analysis. The fragmentation of molecular ions creates a distinct fingerprint for each compound, which can be, invaluable for identifying or characterizing substances in a sample. So, talking about the principle of mass spectroscopy, the main ability of mass spectrometry would be to measure the molecular mass of a compound and to determine its elemental composition. So, this process starts when a molecule is bombarded with a beam of electrons. So, these electrons have high energy, typically around 70 electron volts, which knocks the molecule out of the, which knocks the electron out of the molecule, ionizing it and creating a positive ion. So these ions are then analyzed based on their mass to charge ratio. For most ions, the charge is positive 1. So the mass to charge ratio would simply correspond to the molecular mass of the ion. By analyzing these ions, we can gain a detailed information about the compound's molecular weight and its components or the composition. Moving forward with the applications of mass spectroscopy, the mass spectroscopy can be used in two primary ways. One to confirm the identity of a known compound or to determine the structure of a novel chemical compound. So it's like for first for providing the identity of the compound, where by comparing the mass spectrum of an unknown substance with those of known compounds, we can determine if the unknown compound is identical to a reference compound. And another one, the determining the structure of a new compound. For like the unknown compounds, mass spectrometry can provide crucial information like the molecular mass and molecular formula. It also indicates the presence of specific structural units or a functional group, which is invaluable for elucidating the compound's full structure, basically for analyzing the structure more better. Okay, so now let's talk about what exactly is mass spectroscopy. So, mass spectroscopy essentially examines the ions formed when a molecule breaks apart or fragments under the influence of an electron beam. So, this process begins with the ionization of the molecule. When a vaporized sample is bombarded with electrons, it forms a positively charged molecular ions. So, these ions then break apart into smaller ions and neutral species through a process known as fragmentation. So these fragments are then analyzed in terms of their mass to charge ratio. The resulting mass spectrum plots the intensities or the relative abundance of each of these ions against its mass to charge value. This allows us to reconstruct the important structural details about a molecule and identify it. So once these ions are created, they need to be analyzed. A key part of this process is the deflection of ions by a magnetic field. So these ions are accelerated and then pass through a magnetic field. The degree of deflection depends on the ions mass and charge. So the lighter ions are deflected more than the heavier ions because obviously the mass of the ion decreases, so it's easy to get deflected. So additionally, these ions with the higher charges are deflected more than those with only a positive charge. So this results in a series of beams, each containing ions with the same mass to charge ratio. These beams are then directed to a detector where the intensity of each beam is recorded. The most abundant ion corresponds to the highest peak in the mass spectrum, known as the base peak, which is often set as 100% intensity for reference. So as we can see here in this diagram, first the ionization of the sample takes place, then the acceleration, then deflection and the detection. So we'll be learning about these terms in more detail in the next slides here. So let's move forward. We'll be learning about this entire process in more detail now. So first to begin with the ionization. Mass spectrometers always operates with the positive ions. So the first step in mass spectrometry is the ionization of the sample. What happens in this process is that the sample, whether it is an atom or a molecule, it is bombarded with a stream of electrons, knocking one or more electrons out of the atoms or a molecule. This results in the formation of positive ions. So most of the ions formed in this way have a charge of positive 1. So the ion repeller, which is another part of mass spectrometer, helps expel these positive ions out of the ionization chamber and into the next stages of analysis. Yeah. So the next stage would be the acceleration of ions. So after the ionization, the positive ions are accelerated to ensure all have the same kinetic energy. So the ions that pass through a series of slits, each with a progressively higher voltage, by the time the ions exits the ionization chamber, they form a tightly focused beam. So this uniform acceleration ensures that the analysis of ions is consistent with all ions having the same energy as they enter the next stage of deflection and analysis. So in deflection of ions, once the ions are accelerated, they enter the deflection chamber where they are influenced by a magnetic field. So the degree to which an ion is deflected depends on its mass and charge. So the lighter ions will be deflected more than the heavier ones, and ions with a great positive energy will also be deflected more. So the result is that ions with the same mass to charge ratio follow the same trajectory, forming distinct peaks on the detector. So this deflection allows us to separate ions based on their mass to charge ratio, the values, which is crucial for identifying different fragments of the molecule. So next is the detection of these ions. So as the ion beams pass through the machine, they are detected electrically. So when an ion strikes a metal surface, its positive energy or the positive charge is neutralized by the electrons flowing from metal to the ion. So this process creates a small electrical current. The magnitude of this current is proportional to the number of ions detected. More ions hitting the detector create a stronger current, and the strength of this current is measured and recorded. So the result is a mass spectrum where the height of each peak corresponds to the abundance of ions with a particular mass to charge value. Okay, the final one is the fragmentation process. Like this is very critical in understanding how mass spectrometry works. So when molecules are exposed to the electron beam, they are ionized, forming molecular ions. So when the energy of the electron beam is higher, typically between 50 to 70 electron volt, the molecular ions can become highly excited, causing them to break apart into smaller fragments. So this is what we refer to as the fragmentation process. So the fragmentation pattern is formed as unique for each molecule and plays a crucial role in determining the structure of the compound. These fragment ions can provide insights into the molecular structure, functional groups, and the connectivity within the molecule. Okay, to summarize these, I would like to say that mass spectroscopy is a powerful and a precise tool for molecular analysis. By analyzing a sample, accelerating the ions, and analyzing their deflection and fragmentation, we can determine the molecular mass, structure, and also the compounds or the components of a compound. So, this makes mass spectroscopy useful in many fields like organic chemistry, environmental science, and also forensic science. So, with this, I would like to end this session here or this topic here. So, if you have any doubts, you can put it in the comment section. Also, do let me know what changes you would like to have in the further classes. Also, don't forget to like, share, and subscribe to Forensic Fusion. Thank you.